Hi, welcome to this video series again on material phenomena in nuclear environments. So today we want to talk about getting cross-section data from a certain site called the National Nuclear Data Center, NNDC. So let's Google first NNDC. Okay, so Googling that, it will you look at the first result here, you'll get NNDC. Okay, so you'll see all these pieces of data here, So look on this side of the screen, and you have the NDF, ENDF, the evaluated nuclear data file. Click on this, and you will have you come onto this screen. Alright, so we have discussed that we were trying to find cross-section on iron 56. Okay, iron 56. So 56 Fe, so you can type in any of the notations as long as they are on this left hand side here. These will give you the acceptable notations, and this thing Fe star or Fe asterisk means all the you are looking at all the isotopes of iron. So the reaction we are interested here is the N-elastic reaction. So if you look at this what do you see here? This is N-inelastic. This is the NF, which is neutron incoming and fission reaction occurs. Ng stands for N gamma. N total stands for the total cross section. So you sum up all these reactions, and not just the ones here, every single kind of reaction that's on record, you have the total. So N star will just give you all the reaction, the total, the gamma, fission, inelastic, and all this as well. So that will include elastic. So N star will by default by default give you all the data you need. If you are not sure what the quantity is, you can leave it blank, but we are looking for cross section, so that is sigma, so just type in SIG. Check this and submit. So once you have submitted this, we'll look at the sigma values for N elastic, and just for interest's sake, we might want to look at the N gamma reaction. These are neutron capture. So we have talked about neutron capture before. So let's take a look at neutron capture. Ng is usually Ng. So let's Control F. I'm gonna find Ng. Oh, it's not here. Control F. Where are you? It works in Chrome. Let's take a look. It's iron 57. These are all inelastics. Alright. Yeah, this is Ng, which is correct. The one just now was right. Yeah, so anyway, the reaction notation is this. Iron 56 absorbs the neutron. So iron 56 absorbs the neutron, emits a gamma ray, and iron 57 comes out. So that's what all these notations mean. So again, you look at this, iron 56 absorbs one neutron, spits out two, becomes iron 55. And if you look at this elastic, iron 56 takes in a neutron and it elastically scatters off, and you get iron 56 L0, which is I think the zeroth excited state, basically ground state. Okay, so anyway, we want to plot the data. You can either use this one to plot it here, or use this to plot the selected data, which we have selected to, the n gamma and the n elastic. So n elastic is here, and n gamma is here. Okay, let's plot this out. So we see two cross sections here. The green one here being n gamma, which is the capture cross section, and the blue one being the n elastic. And you can see that this is a log-log plot. So each of these lines represents one order of magnitude change. And you can look at this. It looks like it looks like at the range of our interest, looks like the n gamma, the capture cross section, is way lower than the elastic cross section, which is why we don't usually look at the capture cross sections in our calculations or whatever. Yeah. Anyway, the absorption cross section is very low because it's very low affinity to absorb a neutron. And let's look at cross sections over various energies. So to zoom in, just click here and zoom. So this is around the thermal range. Okay, so it's usually about 10 to the minus 9, 10 to the minus 8. And look at this. Cross section. Okay, if you want to look at the specific values, you can look at you can keep zooming in to the number you want. That will give you the specific value. For example, 5 times 10 to the minus 9 MeV, or basically it's a very low energy, so it's like 0.00 some 005 or something like that, or a little lower than that. So it's 5 times 10 to the minus 3 electron volts. They have a elastic scattering cross section of 12.65 barns. So if you're not sure, you can just keep zooming in. To press the back button, just press this, or I wonder if there's a zoom out. Let's see, zoom out, zoom out. Okay. Never mind. If you don't know how, yeah. Okay, that's the zooming out on this side. Okay, these are horizontal zooming in and zooming out. I wonder if there's a vertical, but never mind. If you're not sure, we can just press the back button and then plot again. It's a very cumbersome way, but it's a way that works. So we want to look at the 1 MeV range. So look at the n gamma is so low that we don't even have to consider it. It's less than 1 bar. But let's look at the 1 MeV, and then let's look at the energies. So incident energy, you can look at here, 1 MeV, 10 MeV, 20 MeV. So we're interested in the 1 MeV. But you look at this, so messy. But these are characteristic of resonance regions. Okay, anyway, let's look at 1 MeV. You'll just zoom in on this part. Okay, and you look at excuse me. You look at all these resonances that are happening here, and if you want the specific cross section, again we'll zoom in. Okay, so it looks like at 1 MeV itself, the cross section is almost less than 1 barn. Can you see here? Okay, it's slightly over 1 barn. My mistake. But so I'm going to press the back button and plot again. Okay, so I'm going to zoom in here. And zoom in here. So you look at the 1 MeV range. The cross section almost is like ranging from less than 1 barn to about 5 barns at maximum. So if we were to look here, zoom in. Yep, zoom in. So exactly 1 MeV is just over 1 barn. But if you look at the resonances, I think 2 to 3 barns on average. If you look at the neutron energies around this region, and you look at the cross section, I think a 3 barn estimate isn't a far off thing. Now, if you want to look at the fusion neutron range, which is about 14 MeV, you can look at here's 10 MeV, here's 20 MeV, so we'll just zoom in around here. You see? This is about 10 MeV, this is 20 MeV. So we're going to zoom in here to find our 14 MeV. So you see 14 MeV is here. Zoom in. Okay, so we are at just nice 14, 14.1, 14.2. You keep zooming in and the accuracy becomes higher and higher. So let's take a look here. Okay, let's zoom back. I think we have exceeded the range or something. Okay, let's zoom in again. Zoom in again. Yep, zoom in again. So look, 14.1, 14.2. Look at the cross section on iron. That's about 1.17 to 1.18. Okay? So this is the cross section at exactly 14.1. But if you were to consider all the energies around that region, it won't be too far an estimate. It won't be too far an estimate to consider that the cross section is around 1 to 2 barns. Just take a look. There's about 1 to 2 barns. We consider the slightly lower energy ranges. Okay. But this is just a demonstration to for you to find the cross section using the nndc site based on nndc. Thanks for watching. I'll see you guys next time. Bye bye.